Okay, last problem from this lecture that we will work says a patient is receiving 3,000 milliliters per day of a solution that contains 5 grams of dextrose, which is like glucose, per 100 milliliters of solution. If glucose provides, here's another relationship, 4 kcal per gram of energy, how many calories per day is the patient receiving from the glucose? Write your answer in scientific notation. So again, I'm going to find my question. Here's where my question begins. How many, and it's calories per day, there's my units, is the patient receiving from the glucose? So I want my answer to have units of calories per day. Calories on top, day on bottom. So I'm going to find, there's 2 places you could start. There's actually multiple ways to do these. And again, if you don't work these problems exactly how I'm showing, that's okay. As long as you show the correct units canceling and the correct steps. If you arrive at the same answer doing it slightly different than how I do it, that is okay. I'm just going to show you how I would solve it. Because I want calories on top, day on bottom, I'm going to start with this relationship right here because I see it also has day on bottom. All right, so I'm going to write out 3,000 milliliters per day, and that is per 1 day. You don't have to write the 1, but you can. Okay. And we have some other relationships too. We have 5 grams of dextrose. I'm going to abbreviate DEX per, and if it says per, this means kind of like acts like a slash or a line, a divider. Whatever it's per goes on bottom, so per 100 milliliters of solution. And we have another relationship which says for kcal, what is a kcal? It's a kilocalorie per gram per 1 gram of energy. Sorry, we don't need to write energy down here. It's 4 kcals of energy per gram of drug. So per 1 gram. And because I see my answer is going to need to be in calories and we're given info in kilocalories, I'm going to go ahead and write out the relationship that for every 1 kcal, we have 1,000 calories. Okay, now this was intuitive. The problem doesn't give it to you, but I see that I need my answer in calories. I'm given information in kilocalories. So this, you had to kind of read between the lines and know I'm going to need to convert from kcals to calories. All right, so now I'm going to start up here where I wrote my first conversion factor. 3,000 milliliters of solution, drug solution per day is given to the patient. We want to cancel out milliliters, all right? And I have a relationship, this first one right here, that has units of milliliters that I could cancel milliliters with. So I'm going to write it as is. I want milliliters on bottom, so that's 100 milliliters of my solution. 5 grams of dextrose. Now we have milliliters on top and on bottom. So those cancel. If we keep going, I don't want grams in my answer. Right now we have grams, and I don't want grams in my answer, so I'm going to use my next conversion factor to cancel grams. And I'm going to write grams on bottom, which it is positioned that way already. So for every 1 gram, it was 4 kcals of energy. So now I have grams on top and bottom. They cancel as well. And right now, if we stopped, we have kcals of energy per day, but we don't want that. We want calories of energy per day. So I'm going to use my last conversion factor to cancel kilocalories. And I'm going to flip this one so that I write kcals on bottom. For every 1 kcal, there's 1,000 calories. 1, because I need to cancel kcals. 2, I know I need calories on top in my answer. So now kcals are on top, kcals are on bottom, those cancel, and we are left with calories on top, day on bottom, which is what our answer would like for us to have. So now we just do the math, 3,000. You can divide by 1 here, you can ignore that 1 because it won't change your answer numerically. So do 3,000 times 5 divided by 100, and then times 4 times 1,000 and I got 600,000. I always double check myself real quick on the calculator to make sure I did it right. 3,000 times 5 divided by 100 times 4 times 1,000. And again, I get 600,000, and that is calories per day. Now we're not done because it says write it in scientific notation. So if my decimal is right here, I need to move it 1, 2, 3, 4, 5 places to the left. And remember, if we move our decimal to the left, the exponent increases. So that was 1, 2, 3, 4, 5. So it should be 6.0 times 10 to the 5th calories per day. All right.